Welcome to the UNL Chemistry Department. In today's video, we are going to be looking at the proper technique and procedure for titrations. Let's get started. Here's what you're going to need: a bottle of KHP, a weigh boat for the KHP powder, a spatula, some deionized water, make sure not to use tap water, your unknown concentration of NaOH, phenolphthalein, I think you're already familiar with this indicator by now, a burette and a burette stand, and some various glassware to measure with, dissolve your KHP in, and collect waste. And of course, anytime you are working with chemicals, you need to be wearing gloves and your safety goggles. I recommend cleaning your burette first because you have no idea who used it last or what was inside of it. In order to do this, you will need to wash it with deionized water at the sink. Typically, you would do this 2 or 3 times to ensure the burette does not have any impurities still inside of it. We use deionized water for cleaning to prevent chemicals from the tap water to contaminate our burette and throw off our calculations later. Next, you need to place your burette on the stand. Using your unknown NaOH solution, rinse out the inside of the burette. While you do this, you need to try to get out any bubbles that may be in the tip of your burette. Bubbles will throw off the accuracy of your titration. For more details on how to properly wash your burette in preparation for a titration, watch the burette technique video linked in the description below. Once you are fully rinsed, you can top off your burette with your titrant. Then you'll need to zero out your burette to get ready for your titrations. Remember, your initial reading does not have to be 0, but will need to be documented for your future calculations. Now we are ready to find the mass of our KHP. KHP stands for potassium hydrogen phthalate and will react with NaOH in a 1:1 mole ratio. Note the formula weight of KHP here on the bottle. You will need this mass for your calculations as well. I am sure most of you have used a balance before, but remember to zero out the weigh boat before weighing out your KHP. Here I am aiming for 300 milligrams of KHP, but getting exactly 0.3 grams doesn't matter all that much, as long as I am close. This may take a while to get close to my desired mass. Any excess KHP should not be put back into the bottle, but disposed of properly. Ask your TA for specific instructions. If you are using this style of balance, make sure to slide the door closed to get your final mass. You will need to document your KHP masses each time you take one. I recommend you weigh out 4 separate boats of KHP for your titrations, but really it's up to you on how many you do. Make sure the balance is clean when you are done with it. Next, you will need to transfer your KHP to flasks that contain approximately 100 milliliters of water. The exact amount of water doesn't make a difference, but the exact mass of KHP does. Remember, this is deionized water, not regular tap water. Rinse your weigh boats out 3 or 4 times with deionized water to ensure you get all your KHP transferred. This technique is called a quantitative transfer. Another technique that you could use is called massing by difference. See the description below for a link to the balance video for this technique. KHP may take a while to dissolve, but it is important to make sure it is fully dissolved before you start your titrations. Here I am doing 4 titrations. The first one is known as a scout titration. More on this in a bit. Next, add a few drops of phenolphthalein. 2 or 3 drops per flask will be sufficient. Now we are completely ready to start our titrations. A scout titration is completely optional. This titration is typically done pretty fast, and it does not need to be super precise. The point of a scout titration is to get a rough estimate of about how much titrant you are going to need to add to the rest of your solutions. A scout titration will only be valuable if the masses of KHP are close to each other. The masses don't need to be equal, but they should be within 25 milligrams of each other. Here my scout titration tells me that I need approximately 15.5 milliliters of NaOH for each of my solutions. Now we can start with our more precise titrations. My scout titration allows me to run the burette down to 13 milliliters before I need to start adding more slowly and eventually dropwise until I see a color change. You need to slow down 2 to 2.5 milliliters before the point that your scout titration indicated. This is because during the scout titration it is very easy to over-titrate without knowing. This process can take a while, but in order not to go past your equivalence point, you need to take your time. Adding your titrant dropwise and stirring intermittently will ensure the best results. Adding a sheet of white paper under the flask can help you see the color change if the black background of the ring stand makes it difficult for you to see. A pale pink is the color that you are aiming for. You will need to titrate the rest of your solutions as well. I will speed up the process so it doesn't take so long. Remember, to get good results, this process does take some time. Don't forget to document your initial and final burette readings. The burette I was using had marks for every 1/10 of a milliliter. We can tell if our volume falls between these marks, so we need to document our volumes to the nearest 100th position. This is the proper number of significant figures for this piece of glassware. Here's a sample set of data if you would like to try a calculation on your own. Pause the video at this time if you'd like to try it out, and I will post an answer here in a few seconds. Here is your average with the correct number of significant figures. Here is an additional tip for you when doing your titrations to help make your results even more precise. You can add half a drop of titrant using your burette by simply turning the stopcock slightly to let half a drop of titrant swell on the tip. By touching it to the side of your transfer container and swirling the solution, you will have added half a drop of titrant. Good luck in the lab.